Hi, everyone. I'm Erin Sawinski. I'm the community and product manager for the Simon Initiative. And welcome to the OpenSimon Webinar series. OpenSimon is a learning engineering community working to improve learning outcomes for individual learners at the same time that we are advancing our understanding of human learning. This series, the first today, will consist of instruction, examples, and demonstrations of learning engineering tools and techniques. It celebrates best practices and applied learning science for members of the community. Today, we're live from the Simon Initiative Summer School, LearnLab Summer School. And to tell us more about that, we have Dr. Ken Katinger.
Hi, folks. Yeah, the LearnLab Summer School has been going on for 19 years. The first one was in 2001. Actually, the first ones were about intelligent tutoring systems. And then starting in 2004, we started to expand different tracks. And this year we had, in addition to authoring intelligent tutoring track, we had a track on developing open online courses, a track on educational data mining, and a very new track on modeling human learning with computational systems, AI, and machine learning. This year, we had a record number of attendees with over 100. Past years, we've gotten up to about 60. We think that's probably an indication that the ideas around learning engineering and learning design, they're ideas whose time has come, and we're excited to be supporting them not only through the OpenSimon tools and techniques, but through activities like this summer school that are providing educational opportunities for people to learn how to use those tools and techniques and code.
Great, thanks, Ken. We're here talking today with 4 participants of the summer school this week. Each attended at least one of the 4 tracks that we offered, and I'll let them introduce themselves, and then we're going to switch over to a slideshow while they showcase their work and tell us more about their experiences. So if you want to start.
Hi folks. My name is Biswajit Naik. I work for a tech company in India. It's Learning. It's kind of social enterprise. So the idea is that there are a lot of these kids in India who do not go to school, and they're kind of marginalized, and most likely they learn in the language of their choice, which is not unfortunately English. And also they are disconnected, which means we have to reach them through different ways than MOOCs and all this. And so that's why I started this initiative back in 2014, when I was kind of initially inspired by Khan Academy's Coursera's here in the US. And today we are running this, you can tell about this women-like centers, and run by young woman entrepreneur who runs this program. And the idea is that of me coming to this Carnegie Mellon, that I learn about the cathedral of learning right here, and then I follow the work that Ken and other people are doing here. And my objective here is that how can I take the best practices in the West and distill myself first and put them in use, and put them in the use in the sense that how can we improve the quality of education for those forgotten children in rural India. That's my research objective, or my mission in life right now. So when I come to this program, for example, I can give you two direct things that I got out of this 5 days. That we are designing some kind of exercises which are kind of very dumb when after this 5 days of program. And then I launched a couple of things in CTAT, in ITS track, that I can use just tomorrow. It's just like the kind of thing that I learned something, I'm going to use, and then I'm going to improve. And then today's thing, I promised that I'm going to do 50 exercises what I have before, the dumb exercise, and make them intelligent tutor. So that is a very credible thing that I'm taking out from here. And I'm very thankful. I'm very privileged to be here. And again, thank you. And for all the kids down there, thank you.
You're welcome.
Sorry.
Sorry about that noise on the microphone.
So, Michael.
Hi, everybody. I'm Michael Feldstein from eLiterate, which is the name of an educational technology weblog and also the company that owns the weblog. I am here this week for a couple of reasons. One is that I've been a fan of the work that happens here at Carnegie Mellon for a long time, and wanted to take an opportunity to do a deeper dive and learn more about it. And I would say to anyone who's thinking about coming that that while you'll hear about our projects in this webinar, there's a lot more value that you get from coming here beyond the projects. Just understanding the breadth and depth of the work that they do here is a privilege. So I definitely came here for that, but I also am working on a project called the Empirical Educator Project with the help of Carnegie Mellon, as a matter of fact, to help encourage cultures of empirical education, of teaching, improving teaching through research on college campuses. And I came here this week to try and learn about how I could use some of the Carnegie Mellon OpenSimon tools to further that goal.
Yeah. Hi, I'm Samiha Marwan. I'm a third-year PhD student from North Carolina State University. Actually, like, my whole work is focused on intelligent tutoring systems, but like, usually when I collect data, I do some data mining, and when I heard about this opportunity of joining the summer school in Carnegie Mellon, I found that, oh, that might be useful in joining like education data mining track, especially that it's like kind of supervised by like people who are like very famous in this field. So yeah, I think that would be like a really good opportunity for me to investigate more in my data, and actually like I have learned many like skills that I did not have before. So my project that I was working here was more about how can like predict students struggle while they're doing programming. So actually this has been done before, but maybe I just did it in a different way, which is I try just to know, like, from students' point of view, like, how do you think, like, how can you measure actually how much you are struggling? And then we collected these responses and tried to like kind of see like if there's kind of correlation between the students' actions and the responses, and try to build like a model that can predict that. So I got some nice results. I hope that it like still like I need to test this more and like different data just to make sure that it's accuracy as well, and maybe I can integrate it to our system that can just predict like actually while students are working during runtime, it can just predict that they are struggling and then just give them a kind of feedback. So I think that would be really useful if it happened. Yeah, actually, like not even the project that I did here was useful. I really liked like sharing ideas with other people. Like I feel like I'm having new research questions that I have when I go back to my lab. So I think this really interesting. I got really lots of feedback on my work, and some of them are really useful, which I really appreciate. Yeah, so that was another nice thing, and I really like hope to participate next year, hopefully. Yeah, and I just want to thank you all for giving me this opportunity. Thanks.
Hi, my name is Sarah Huber, and I am a senior learning designer at Cengage, which is an ed tech publisher. And the reason that I am here is we, as a company, obviously are very interested in personalization and how AI and machine learning can really help us to develop personalized and tailored learning solutions for students. So because of that, I took the computational model learning track, and I'll get into this more when we have my slides up, but the two biggest things that I've learned this week, both from the project and then also the lectures throughout the week, were number one, when I'm designing course experiences, I really need to remember the assumptions that I bring to the table, and Ken talked about this a lot this week, but just being aware of the expert blind spot that exists, and the things that I assume that learners already know coming into a course that may not be the case. And then the second thing is the idea of not just applying learning science and learning principles to the design of an instructional strategy, but actually testing that in what can termed learning engineering. I again, is something that I really want to take back when I go back tomorrow. So again, thank you for the experience.
Great. So now we're going to switch over to some slides and talk through them a little bit, and maybe the sound might be better that way when we're getting closer to the microphone. Thanks for your patience, everyone. I hope you heard that, but also know that we're recording this, so the recording will be available on the OpenSimon website early next week. So let me switch over to just the slide share. Okay. Let me see what the chat had to say. Okay, yeah, so much better. Okay, so yeah, come on up.
Yeah.
Okay.
Already done, right? Yeah, so this is what I'm going to say here is that this is my old question, that if you see that I am just giving them so this is in the local language, so that is one of the design goal that we have, because the kids in the rural places do not understand English. So here we have given a math problem to find the shape of a area of a shape. And as you see, we're just going to ask them only one question, just put them. I don't know, how they compute it. If somebody's counting 1, 2, 3, 4, like this, or if they are decomposing the big shape into smaller shapes and doing this thing. So this is one of the problem that I had. I do not know how they're doing. So that's what I learned in ITS, is that you can really decompose that same problem into different things, so that they can you can understand how they're doing, what is their mental thinking, So, and also I by doing this thing I can know if they're knowing how to multiply, if they know how to add them up, and all the steps that is so useful. That I didn't know these things before. I was doing this thing for the last 4 years. And also I have seen this kind of thing in other learning tools that I am exposed to at least. So this is a version that I built during this during this week. And also another thing that we have a use case that this should work offline. That's very important, because as I said, 4 billion people are not connected, and we want education to also reach there. And what I do, I have a device, so which I import, I basically export all this course I built online and put it. And if you see here, it's some 2.2.2, that's my own device that has a Wi-Fi hotspot. So that is all self-contained, self-packaged. And I also see how can we track the logs, and also we have a mechanism to export these logs. Of course, it's not happen right away, but by USB or CD, we do this thing. So so this is the work that I did, and can we just do that thing?
Yeah. One moment, please. I'll share these slides.
Okay.
Are you guys seeing the right slides now? Yes. Great. Thank you, guys. Thanks for your patience.
Can you
too.
minimize that one, please? Minimize this chart. Okay, so my immediate goal is what I learned today, I'm probably going to use tomorrow. That's what my thing. And already this thing, I'm trying to do this pilot and get data. So immediately we're trying to convert 50 assessment that we have in this format to the ITS intelligent tutoring system. So that's kind of a big goal, but I think we can do it. And then we are running today about 106 learning centers, catering to 17,000 students. No Google, no Facebook, no internet have reached them. So essentially, and these are the kind of data maybe people here might be interested to do research, because these are kind of tribal areas, this kind of different kind of ethnographies and all these things. And we want to run, that's the goal by December, hopefully we can start running in 50 centers and targeting about 5,000 students, get this thing work doing, and then understand, if this thing really working, or what kind of these things needs to be tweaked. That is what I learned, that don't, you have to believe based on evidence. So that's my, next year goal. And I'm hoping I'll again come back next year with a lot of data based on my intelligent tutor. Either I can do a CML or a EDM, and that's my goal. And yeah, if you have any questions, I'm available at biswajit@abetilearning.com, or biswajit@sikhya.org. Thank you.
Thank you so much. Okay. Next, we have Michael Feldstein.
Hi again, everybody. So, as I mentioned in my previous answer, we're really interested in getting instructors and faculty to engage in empirical practices to be continuously improving their teaching. And there was really interesting 4-year study done here at Carnegie Mellon University. You can read some of the results from anthropologist Lauren Herkes that showed that faculty attitudes towards adopting evidence-based practices is complex. And I won't go into a lot of the details now about what all the barriers are, but some of them are surprising. I definitely recommend looking up her research. But we're looking at developing a range of interventions that would address some of the faculty's real concerns. And the ones I want to talk about today have to do with not their barriers to get to the decision to try something, which is one of the questions that we're interested in, but also once they decide to try something, why do they fail? And often faculty try something, a flipped classroom, use it clickers, whatever it might be, and fail because they're approaching the implementation in a very instrumentalist way. They see a particular problem that they need to solve with a class design that they have that they otherwise often feel pretty good about. And so they'll go in almost the way you'd go in to try to fix your Apple TV that's not working. It's very focused on, I have a task, I have a thing that's broken, I want to fix it. And if they miss the larger context around, for example, what are the challenges with implementing flipped classroom, and they might miss some of the critical details that would help them implement successfully. So we're thinking about using OLI-based tutors to address 2 problems that are related to this instrumentalist approach. One is to challenge them directly in their thinking and get them to first have them approach a given problem like a flipped classroom or something hopefully more specific than that, get right to what they need to get done, but to frame it in a way that challenges them to think about it as an experimental design and asks them inquiry questions, gets them to think about what might go, what they might go wrong, what they can find out. Sometimes just thinking about what you're about to do in your classroom explicitly as an experiment with the design where you're getting feedback can help mitigate risk because you're thinking about variables. And the second thing that we want to try to address is help-seeking behavior. Because often when faculty are approaching this problem in an instrumentalist way, they'll ask the person who they trust to give them a brief, straightforward answer, which is the kind of answer they're expecting that they need. So they'll go to a colleague who's implemented before, or they'll go to the vendor who provides a tool that they're going to use, instead of going to their Center for Teaching and Learning or to their local instructional designer for help that might engage them in a deeper discussion. So if we embed these tutors, we can, again, get directly at their instrumentalist problem, but prompt them on areas where they're likely to run into problems. And since these tutors are open and customizable, even give them very specific clues about when they might seek help, about what, and to whom they should go for help. So in addition to addressing those 2 goals, of course, the tutors will allow us to gather data, which is really important because there's a lot we don't know about faculty barriers at this point and attitudes towards implementing technology, including, for example, whether they'd be willing to take a tutor. So we'll be getting some of these hopefully in the field there'll be one unit for an instructor and a companion unit for a Center for Teaching and Learning staff person, for example, on each type of intervention that we develop a tutorial course for. And we hope to come back to you with some results.
Great. Thanks, Michael.
Thank you.
Okay.
Hi again. Okay, so yeah, so as like according to my previous answer during when I'm introducing myself, I talk that my main focus is intelligent tutoring systems, where again we excited in like giving students automated feedback while they are doing programming. So actually why this is important, because usually like in programming, like usually students they might feel like kind of struggling, and also there's no like one specific answer for them. Like every student might have his own way of solving a specific problem, so maybe like for each student we need to have different answer, so you can like think about the large number of possible solutions in programming. And that's why we are interested actually in developing these systems that can provide automated help to students. So actually I'm working in block-based programming languages, and they are just like different than text, where the students like drag and drop blocks, like as you see here. I'm using Snap, and this actually is used for high schoolers and also for undergrad students who in Introduction to Computing courses for non-majors, for non-CS majors. So yeah, it has been widely used actually. I'm working on this environment, and actually we wanted to think of what about like having a system that can predict if a student is struggling during runtime, like while I'm working, I'm doing some programming. If I'm struggling, the system can predict this, and like for example, at this point, give me a hint. So instead of just waiting for me to ask, or just waiting for the student to ask for a hint, why not just to predict actually if you're struggling or not? I think this will be really helpful, especially that highly performing students, they actually don't need help, right? But for example, like low performing students, you need like lots of help. So it kind of be like we're making like the system more adaptive to students. It depends on like how you are performing, and then this is how much help you need to have from the system. So this is like the motivation of my project here that I did in CMU. So my specific like part about the project that I did here is that I want to build a system I want to build a model that can predict how much student is struggling. And the way I did this is that we had a study where every 2 minutes we asked students, how helpful would it be to receive some help right now? And then we asked them to give like a rating on a scale from 0 to 10. And so the higher ratings, this means that the student like need more help, and then this means that the student is struggling, so he needs help. And we tried actually to find either like any type of correlation between the type of actions the student did during this 2 minute frame and response. For example, I did like action X and then Y and Z and then X and kind of like this for 50 times, for example. And then I give a rating of struggle that, hey, I'm struggling like 10. I need like help with a scale of 10. So we wanted to see actually a zero relation between the type of actions and the response. And based on this, we can predict if the student, how much the student is struggling. And in like which was something like nice that we found actually that yes, there are specific actions that when they occurs in the data like frequently, this means that most probably, or actually, yeah, this means that this is kind of like significantly predicting that a student is struggling. Like for example, this is like kind of action called create block, like if a student like keep creating block. If you see here that the estimate is like negative, which means that the more actually students created block, the less they are struggling. So it's like yeah, this is like why, because of this negative value. So this is kind of like new or like actually like surprising result. I saw that if students like keep creating all blocks multiple times, this means that they're really struggling. However, we found out that from our data that this is completely the opposite. If a student like is creating blocks more time, this means that they are less struggling. Maybe this means that if a student actually is struggling, this means that he will not work, he will not do any he will not create any blocks. So maybe just keep idle, staring at the screen. So yeah, this is maybe like kind of interpretation for this. So we found also other user actions that can be good predictors to students' struggle. So our next step from this is that I want actually to see if there's any other effects. For example, the order of the actions, like now all what I like checked here, just the frequency of the actions. But also I want to check if there's a specific order that when it happens, does this mean that the student is struggling? So this is one thing I really want to investigate more on it. Also, I want actually to test this on different data set and see actually if I'm getting like the same, just to check the accuracy of the model, that you can like work on different people. Because again, this is just done for I think 208 students. So maybe like if I like check it in different data sets as well and see how this can be accurate. And if this is successful, which I really hope so, then we can deploy it in a system. And then while the student is working, the system can just automatically predict if he's struggling or not, and based on that, give them a hint. I think this would be like really super cool and nice for students. If you want to know more about my research, so this is my name and this is my email, so feel free to email me. And thank you. And yeah, thank you so much.
Thank you so much for sharing your project. So last but not least, we have Sarah.
Hello. So like I said before, I am from Cengage, and therefore I came to this week a little differently than the rest of the people here. So I did not have a specific research project that I was working on prior to coming here. Frankly, I was just very interested in what Carnegie Mellon is currently doing as far as machine learning is concerned, and adapting to student responses, that kind of thing. So I was lucky enough to, in the computational model of learning track, be paired with one of my colleagues at Cengage, as well as an instructor who teaches statistics. So we decided this week that what we really wanted to do was test or create a tutor and then test said tutor for teaching in a simulated student how to teach or how to calculate the mean of a given set of problems. So the idea, obviously, going into this, was that the difficulty of different data sets would result in more processing errors and more and a longer amount of time to answer the question correctly as well. As you can see on here, we define difficulty as something very specific. So again, I come from a learning design background. My colleague is an instructional designer. So we identified difficulty as something that includes the data complexity. So larger numbers would presumably be more difficult for human learners. Problems that would result in non-whole numbers would also presumably pose challenges for human learners. But we decided not to test those this week because after speaking with our mentors, they gave us the idea or the impression that when we are working with this simulated student model or agent, we really need to think of it as if it were a student with a calculator. So a student with a calculator wouldn't struggle with those two items quite as much. So we really constrained what we defined difficulty as the number of data points. So we presented a range of 80 problems where there were 1, 2, 3, or 4 values that needed to be calculated for the mean. So we did two things with those problems. So the first thing that we did was we tested the two. So first of all, I should also back up a little bit further and say that in addition to being interested in what's going on at Carnegie Mellon and really wanting to dive into the programs that they use here, I myself did not have any programming experience prior to this week. Neither did my colleague, and the third person in our group seemed like he kind of picked up on things a bit quicker than we did. So I'm not convinced that he had never been exposed to Python before, but we were all very limited initially coming into this. So I was a little apprehensive in the beginning, a little worried that I might be in over my head, but throughout the week we were able to not only create a tutor using the CTAT authoring system that they have here, but also then test said tutor against
simulated students, and then also get data from that we were able to analyze. So for my own part, I'm just very proud that we were able to accomplish so much in a given week, considering the lack of prior knowledge that we had before this. But then I'll dive in a little bit more. So what we did with those problems, so again, we had 80 problems with just random values that we wanted to see how long it took to master the skills involved in calculating the mean. So we define the skills as the summation, the count, and then actually dividing those two. So we did this as two different trials. So one was just a random set of questions. So we did it with 50 agents, and all 50 of those agents received all 80 of those problems. So there was no tracking of mastery in that. Versus we also ran one with a BKT-based sequence that tracked mastery of each of those individual knowledge components. And so it only served up the necessary amount of questions before it determined that an agent had mastered each of the knowledge components. So there were a lot of things that we took away from this. One of the most obvious was the efficiency of the BKT-based model, because in tasks that the agent was able to master in the amount of problems that we had and the amount of time that we did this, so for example, the numerator, adding all of those top values was determined to be kind of one of the easier tasks for the agent to master. It was able to master it much faster with a lot less number of problems in the BKT-based method versus just randomly being generated all of these problems. The students had already mastered it, but we were just continually throwing problems at it. So that was something that was not surprising to find. One thing that I kind of alluded to earlier that surprised the whole team was that again, taking a step back and remembering the difference between what may be challenging for a human learner and what may be challenging for a computer version. And for human learners, you just assume that if you're learning how to calculate the mean, you know how to count. So that was something that we hadn't even thought about as an issue in the beginning. So we did do this 3 times. The first time, we didn't even account for that as a necessary piece of prior knowledge. The second time, we tried to do it, and again, I'm not a programmer, so I'm not entirely sure what it was that we were programming as a function, but we were trying to just constrain it to recognize that you can't put any values for that denominator. It has to be somewhere between 1 and 4. Well, that didn't really work either. So then we programmed a function that was intended to actually just count. It was just a counting function. And as you can see in the graphs down here, this is the denominator overall for both the BKT and the random here. And the random, you do see more of a semi-learning curve. I will say that the data for the BKT is a little wonky because it's not wonky, but it's not an apples to apples comparison because we only ran 15 agents on the BKT model, just mainly because we ran out of time. And then we did 50 agents in the random. So it's almost like it's zoomed in a little bit more on the BKT side. But as you can see, the denominator was what it struggled with the most. So again, what I take from this as someone who designs learning experiences for students is, again, what I had mentioned before, just not assuming what their prior knowledge is. And really, when you break down an activity into the knowledge components that go into that, truly knowing that you've broken it down to the smallest number of things. So to us, count was just, you just count. That's an easy knowledge component, but it really involves so much more than that for someone that has no experience with counting. So yeah, I took away a lot from this week. Like I mentioned before, the biggest thing was taking a step back and remembering that just because I know something or I assume that someone knows something does not mean that that is actually prior knowledge going into a design of a course. And then also just the need to continually test. So while this was a very small entry into this world and testing this tutor, we do plan on expanding on this. The group has already decided that we're going to continue it and continue to test. So that's again something that beyond just this project, I plan to do some more within Cengage as well. Right now we do a lot of data tracking as far as like preference on the part of the student and instructor, but we could do a lot more, and I plan on fighting for doing a lot more as far as efficacy and truly validating the decisions we're making.
Great. Thanks, Sarah. So I should let you all know that you've just been exposed to basically some fire hose presentations that were developed right here during the course of the week. And the last day of summer school today, the participants give these talks to the rest of the audience. So it's a really interesting and fun experience. And thank you all again for coming and sharing your projects and talking with us. I'm going to now ask, since we have some time left, if there are any questions from the audience. You can either speak up or put it in chat. Let's see. Any questions? No questions?
Can I jump in with it? This is Ken Kadiger. I hope you got a sense here in this last project how I think actually pretty amazing it is that we're at a stage where we can have a machine system that simulates human learning and shows this kind of, it's not a magical system that gets it right away. It really has this sense of, I hope, at least a sense of realism, as with, that learning is a struggle, and the system indeed makes mistakes. Maybe sometimes some of them are unrealistic, right? But there's a real potential here for adding a powerful theoretical tool to the instructional designer's toolkit. And I think one of the things that a lot of these projects in this track experienced is that they first built an interface to support learning of some complex problem solving, as you did here, right? And then I think in many cases found that the simulated student couldn't succeed because there was too much of an expectation for the student to learn to make kind of big leaps of inference. Then it redesigned the interface to add scaffolding intermediate steps, and then the simulated student was able to learn. And that might actually be just what our real students need in breaking into the expert blind spot. So yeah, I hope we look forward to a chance to see if any of these things essentially, as we say, close the loop, where we could show in an experiment later that more scaffolded interface really does aid human student learning as predicted by this theoretical simulated student. I mean, this is I say theory, but it's a functioning theory. It really does learn this stuff, right?
Great, thanks, Ken. Well, I'm not seeing any questions. Any closing remarks from our participants? Did you guys have a fun time this week? Yes?
Best time.
Best time.
Yeah, I'd just like to say that I highly recommend this. I think it was extremely meaningful and impactful for all of us. And if anybody's interested in, obviously, like everyone's given their contact information, I'm sure you can send it along as well. But like if you want, more one-on-one information about how this was, like, I mean, I had a great time, and I'm sure that you guys all did too.
Definitely. Like, for example, I never been to a university myself, but I've been coming to here and then doing this thing is just amazing.
Great.
Even the food was good.
That's a ringing endorsement for sure.
And also thanks to Jonathan, who was really a mentor here.
Yeah.
And he stayed almost every day at 8 o'clock.
Oh, wow.
PM,
Yeah.
helping us and making this thing happen. And then a lot of times things doesn't really work as you expect.
Right.
And I've seen that kind of dedication distance kind of.
Things just work all the time.
Yeah, right.
I don't know, like Jonathan, the big thank you.
Oh, I'll definitely pass it along. Yeah, we had some great mentors, and all of our participants get mentored and actually support each other too through their work as they share their ideas.
Yeah,
Yeah.
the communication was very friendly. Like, even if you have mentor, you can ask other people as well. Even your mentors can show you other mentors and like, he's more expert in this part, you can talk with him. So they're really nice. Like, not even getting information or knowledge from my mentors that I get from people as well. So that's really super nice. Yeah.
Well, that's, I think, really what we intend. And I know that's what we intend with OpenSimon as a whole, is to start bringing people together who have like problems and helping everybody kind of collectively solve them together. So I'm glad that you guys all had this great experience, and thank you again for coming and sharing your work. And I appreciate all of you out there who joined the webinar. And I just want to close by saying, look for more webinars to come. I'll be posting the schedule on our website, and let me share that. So look for that coming in the coming week or so, where we'll have a whole series, probably webinars happening about once every 2 weeks. And so hope to see you join those as well. And again, thank you, everyone. And I'll look for this recording too on our website at this address. And thanks again. Thanks. Bye, everyone.